So it looks like we've got a couple more people filtering in here, so we'll just give them a moment to get logged on before we get started. All right. Looks like we've got folks joining us here, so I think we can go ahead and get started. So welcome everybody. To start off this evening, I would like to respectfully acknowledge that I am joining this webinar from Treaty 6 territory, and I acknowledge the many First Nations and Métis whose footsteps have marked these lands for centuries. I honor and respect the elders of the past, the present, and the future, and I ask that since we are dispersed throughout Alberta this evening, that each one of us personally acknowledges the Indigenous peoples of your region. I would also like to humbly acknowledge that the recent discoveries of unmarked grave sites at residential schools across Canada tells a truth long known. We know these discoveries open wounds for many people, and our hearts are heavy for the lost children, their families, and the survivors living with the news of these findings. So once again, I would like to welcome everybody to our session this evening. My name is Janine Higgins, and I am an engagement and education specialist with Alberta Environment and Parks, and I will be your facilitator for our session tonight. So just so everybody is aware, this session is being recorded and will be posted on our YouTube account later this evening. So for our agenda for our Upper Athabasca Region Surface Water Quality Management Framework engagement session tonight, we're starting off with a couple of housekeeping items, reviewing our agenda, of course, and then going over how our question and answer will work later on in the evening. We're also going to hear a presentation on the draft framework itself from Sarah DePoe coming up shortly here before we move into a question and answer session. So we'll be closing this evening at 8 p.m. Tonight. So for our question and answer, you can open up at the bottom of the screen. You should have a black bar there, and if you click on the Q&A tool that you can see there, it should open up a white box, and in that white box is where you can type in your questions for this evening. So we'll be taking questions all throughout the presentation that Sarah gives, so if something pops up, you can go ahead and type your question in. And if you see a question that you actually would like to hear an answer to, you can go ahead and hit the upvote button. So that's just one of the ways that we're going to be sorting through questions for this evening, is by hitting the upvote button. So again, if you read through the other questions that have been submitted, that's one way that you can help us determine which questions we're going to be answering next. So we also asked you to submit questions when you registered for the webinar as well, and we will be going through those. So that's how we'll kick off our question and answer session. We'll be responding to some of those, and then we'll move into the live questions, and we'll try and respond to as many of those as possible throughout the evening tonight. So because everybody can see the questions that you're submitting, of course, please keep it clean. If there's any inappropriate questions, we'll just be deleting them from the system, but I'm sure that won't be a problem for tonight. So if we do have similar questions, we may group them together or paraphrase them so that we can get through as many questions as possible. And if there happens to be a question tonight that we can't actually respond to, we're going to defer it, and we will follow up with you through our alberta.ca webpage. So on the webpage itself is where you would have found the registration link for tonight, as well as all of the other resources. And we'll be following up through that page, as well as directly contacting people who we can't respond to their questions if that happens for this evening. So with that, I would like to introduce our panel for tonight. So we have our lead presenter, who is Sarah DePoe, our Director of Cumulative Effects Management Planning, who you're going to hear from shortly here. And then again on our panel, we have a whole bunch of subject matter experts from across Alberta Environment and Parks who are going to be helping to answer your questions later this evening. So from the Upper Athabasca region, we have Curtis Brock and Nathan Ballard. From Watershed Sciences, we have John Orwin and Craig Emerton. From Water Policy, we have Jacqueline Schmidt. And Jacqueline is not on the call just yet, so you won't see her on the screen, but she will be joining us shortly as we get started in the presentation. And then from Land Use Planning, we have Kim Lalonde and Chantel Ladle. So we also have a few other people on the screen who you can see. We've got Jenna Curtis and Rob Harris and Alyssa Robb and Lisa Neem. And these folks are all going to be helping on the back end of things. So while they've got their video on now, you'll see them sort of disappear throughout the night and helping us to make sure that our technology runs smoothly as we're going through our evening. So with that, I would like to pass it off to Sarah, who is going to take us through our presentation now.
Excellent. Thank you very much, Janine, and thank you very much for attending this evening. If you've joined us, it's because you have an interest in the development of the Surface Water Quality Management Framework for the Upper Athabasca region. In this webinar today, we'll be discussing what a surface water quality management framework is. We'll be talking about what it brings to our system of environmental management. We'll be talking about some key components of the proposed framework and how it would work once it's implemented. Some of the folks online may be very familiar with environmental management frameworks and may have attended the webinar that we held on Tuesday on the North Saskatchewan Region Framework. If so, some of the content this evening will be familiar, but for others, it might be new. It's our desire that this webinar tonight will help you and your organization to provide input back to Alberta Environment and Parks on the development of the framework for the Upper Athabasca region. And that if you have any questions, that you'll feel free to ask them. There is an online survey that's open until September 17th, through which we are actively seeking your input. Before we dive into the details of the framework, I thought I'd start by introducing you to the region. The Upper Athabasca region is one of 7 land use planning regions in Alberta. It covers about 83,000 square kilometers, or just under 13% of Alberta's land base. Some of the populations in the region are shown on this map. The Athabasca River, shown in blue, flows through the center of the region. It flows by Hinton, Whitecourt, and the town of Athabasca before exiting the region, where it flows past the city of Fort McMurray and empties into Lake Athabasca. There's a long history and ongoing Indigenous use of this region. This region encompasses the traditional territory of Treaty 6 and Treaty 8 and includes several Métis settlements, communities, and organizations. The Athabasca River is a mountain-fed river system with its headwaters in the Rockies. It originates in the Columbia ice fields. Pictured in the inset here is the glass-floored Glacier Skywalk. It offers beautiful views of the ice fields, or to the origin of the longest undammed river in Alberta, the Athabasca River. The river flows through Jasper National Park. The areas both inside and outside of the park are valued for recreation such as rafting, canoeing, and kayaking. This river also provides source water for drinking for many Albertans. After leaving Jasper National Park, the Athabasca River passes through the town of Hinton and makes its way northeast to the town of Whitecourt. The Berland River joins the Athabasca River in this stretch. The region is home to abundant wildlife. The river and its riparian area provide habitat for a variety of plants and animals. Elk and Rocky Mountain whitefish, like the one pictured in the inset, are iconic species that call this region home. After leaving Whitecourt, the Athabasca River passes through the town of Athabasca and carries on northward to the Lower Athabasca region. The Pembina River, pictured in the inset at Pembina Forks Provincial Recreation Area, joins the Athabasca near the hamlet of Flatbush. River flows in the Athabasca are highest during the summer and lowest during the winter, and it's ice covered from mid-November until about mid-April. This river is valued for tourism, for recreation, for boating, for fishing, supporting healthy aquatic life, providing source water for people and livestock, supporting traditional land use, and providing habitat for a wide variety of plants and animals. Having clean water running through our rivers is something we value as Albertans, and today we're talking about the quality of water in this river and how to manage it. So now that you're situated, you might be wondering, why a surface water quality management framework? It's related to the fact that all human activity can affect Alberta's water resources and aquatic ecosystems. These activities include the things we see in our landscape day to day, such as our towns and villages that will continue to grow as our population increases, our roadways, agricultural lands, including croplands and livestock operations, forest harvest areas, pulp mills, aggregate, other mining, industrial development. This development supports a thriving economy and the quality of life of Albertans. All these activities are managed individually, either through stewardship, through best management practices, through policies, plans, or through our regulatory system. But it's also important that we're managing them collectively. Our surface water quality management framework, we're taking a cumulative effects management approach, which means we're looking at managing water quality considering all human activities that can affect water quality in this watershed. So that includes both point sources and non-point sources. This approach is intended to ensure that our environment is protected and sustained into the future, so we can continue to have clean water for drinking, for recreating, industrial, agricultural, and human use. Understanding cumulative effects is essential to making informed decisions about land and water management and about resource development. The Surface Water Quality Management Framework establishes an approach to monitoring and managing long-term cumulative impacts of human activities on water quality on the main stem river in a region. So we're talking about the Athabasca River. The development of surface water quality management frameworks isn't new. It's ongoing work of our department. Similar frameworks are already in place for 2 other regions. The Lower Athabasca region, this framework was established in 2012 with the Lower Athabasca Regional Plan, and the framework for the South Saskatchewan region that was established in 2014 with the South Saskatchewan Regional Plan. Both these frameworks include monitoring, evaluation, and reporting on surface water quality conditions, and a commitment to respond to declining conditions through government action. At this time, we're proposing to complete the work of the development of frameworks for the Upper Athabasca and North Saskatchewan regions, so including the North Saskatchewan River, the Battle River, and the Upper Athabasca River. These 2 rivers, the North Saskatchewan and the Upper Athabasca, have their headwaters in the eastern slopes. A specific note with the addition of the Upper Athabasca framework, will it have coverage of the entire Athabasca River watershed through a surface water quality management framework, from its headwaters in the mountains through to Lake Athabasca. Similar to other frameworks, we're going to establish a plan, do, check approach. So it's essentially an adaptive management cycle. What these frameworks do is they establish a regular cycle of monitoring, evaluation, reporting of conditions at the regional scale. They create a clear process to respond to current or emerging water quality issues in the river. They set indicators and thresholds to support the achievement of regional objectives, and they require that decision makers consider the findings from the framework reporting in land and natural resource decisions. These frameworks do not replace other aspects of our environmental management system. What they do is they add that regional scale cumulative effects management perspective. So as depicted on this slide, the overall water quality management system in Alberta operates at multiple scales, from the provincial policy level down to the local project level approvals. So at the provincial scale, we have high-level strategic policy direction that comes from the Alberta Water for Life strategy and from land use framework. It's a land use framework that provides important and enabling direction for regional cumulative effects management. Underneath this regional scale, you'll find the nesting at the sub-regional scale, which might include plans such as water management plans. At the local project level, water quality is primarily managed through operating approvals under the Environmental Protection and Enhancement Act, but other legislation, such as the Water Act, the Agricultural Operations and Practices Act, or the Forestry Act, may also come into play depending on the activity. We'd be remiss if we weren't mentioning watershed stewardship in the watershed. Many stewardship organizations are doing great work at the local level. Watershed Protection and Advisory Councils, such as the Athabasca Watershed Council and the Lesser Slave Watershed Council, are multi-stakeholder nonprofit organizations that have been active in this watershed for over a decade. There have been state of the watershed reports, watershed management plans developed, including most recently the Lesser Slave Integrated Watershed Management Plan in 2018 and the draft Athabasca Watershed Management Plan in 2021. So these WPACs and watershed stewardship groups have a really important role to play in both framework development and implementation. In this part of the presentation, I'm going to walk through some of the key components of the framework. We'll walk through all 5 components, starting with regional objectives, the indicators, management thresholds, management response, and reporting and evaluation. So in a cumulative effects management system, in addition to being place-based and tailoring these frameworks to the needs of different regions, the approach is also outcomes-based. So this means we have to start with the end in mind, so defining clear objectives. Each surface water quality management framework has a regional objective that reflects the needs of the region and determines how surface water quality should be managed. The regional objective then guides the content and the direction of the surface water quality management framework. As I mentioned earlier, there is a surface water quality management framework in place for the Lower Athabasca River under the Lower Athabasca Regional Plan, and that's the area that's outlined in black. The regional objective under that framework is that water quality in the Lower Athabasca River is managed for the protection of current and future uses. So current and future uses of river water can include supporting aquatic life, recreation and aesthetics, providing source water for industrial uses, agriculture, or raw source water that provides drinking water for people. Regional objective that's consistent with that used for the Lower Athabasca region could be applied under the Upper Athabasca region. If so, an example of the proposed regional objective would be that water quality for the main stem Athabasca River is managed so that current and future water uses are protected. So it would be a consistent objective for the entire watershed from headwaters to Lake Athabasca. At this point in time, we're seeking input and feedback on the regional objective statement for the Upper Athabasca Surface Water Quality Management Framework, and you can provide your feedback through the survey. Once we have the objective defined, the next step is to identify indicators that can be used to assess water quality conditions. These indicators help to indicate whether that regional objective is being met. For example, it can tell us whether water quality is suitable for the identified uses. Similar to other frameworks, we may include indicators such as nutrients like nitrogen and phosphorus, metals like iron or cadmium or selenium, major ions like sodium or chloride, or indicators such as fecal bacteria. These indicators are aspects of water quality that can be measured. The indicator selection for a framework is informed by our long-term surface water quality monitoring network in Alberta. Our long-term river network, or LTRN program, monitors over 100 water quality parameters at stations located in watersheds across the province. This photo shows Alberta Environment and Parks staff in the field collecting water samples, and the map shows the stations from both our long-term river network, shown as the green dots, and our tributary monitoring stations, shown as the red dots. Sampling at these stations occurs monthly for a core suite of water quality parameters, and there is enhanced monitoring at select sites tailored to either local or regional issues. Water quality in the river is a reflection of both natural factors as well as human influences on the river. Many studies have been conducted in the region. Our current understanding of water quality indicates that surface water quality in the Upper Athabasca River is generally good. It's variable over time, and this is due to both seasonal and annual changes in hydrology. Runoff can cause total suspended solids and turbidity to increase in the river during spring melt and during heavy rainstorms. We've noted that water quality variables tend to improve with new technologies and improved management practices such as wastewater treatment. We've also noted that in some parts of the basin, we may observe low dissolved oxygen in winter, areas of nutrient enrichment or higher trace metals or higher sedimentation. Understanding some of the key pressures and characteristics of water quality in the region is used to inform indicator selection under the framework. We're also looking at connections of the indicators with specific land use pressures on the landscape and the watershed. Certain indicators provide really good measures of overall water quality. So for some examples there are some that are associated with some of the pressures such as urban and residential use, agriculture, forestry, oil and gas, mining, and pulp and paper. So you can see there's red check marks for general indicators for each one of those pressures. Other indicators are tailored to certain specific pressures. So you can see, for example, dissolved and total metal indicators are associated primarily with either urban or residential development, oil and gas, or mining. Under this framework, we have a total of 31 indicators that are being proposed. We used a suite of selection criteria to identify those indicators that would be monitored under the framework, and some of those things that we considered are listed here. We considered the availability of historical data from the monitoring network. This is really important because we use that historical data to establish the management thresholds that can tell us whether water quality is changing relative to what it was historically. We're also looking at whether indicators are reflective to the land use pressures, as I mentioned already, and whether they can be influenced by specific management actions. We'll be looking as to whether we've seen any increases in certain indicators at specific stations, or whether we've seen them exceed surface water quality guidelines at any point in time. We'll be looking at our existing studies, reports, and agreements. So looking at studies that I cited previously, or at the Lower Athabasca Surface Water Quality Management Framework to make sure that we can have a good alignment there. And we're also seeking feedback from our engagement processes. I mentioned the importance of having historical data, and that we use those data to establish historical conditions. We found that in some cases, we might not have enough data for some new or emerging substances of concern to incorporate those as indicators at this time. Likewise, for some of the stations within the region, we might not have a long enough period of record to be including them all. So that can be a limitation. We do want to have those historical data to establish the management thresholds that I'll talk to in a bit. Under this framework, the proposed water quality indicators and monitoring as follows. That surface water quality monitoring would happen at the LTRN station at the town of Athabasca, and that we would include a total of 31 indicators. We're engaging on this list and the selection criteria to get input on whether we've got it right, or whether the proposed indicator list needs to be tweaked at all. So we're really looking forward to your input on this. The next thing I'll talk about are management thresholds that we establish for each one of these indicators. It's something that we can use to evaluate condition against. So management thresholds can include triggers or limits. So here I've got a bit of a graph to define what each one of those are. The limits are shown in red, are the upper bounds not to be crossed. These are based on the most stringent surface water quality guidelines that exist for any given indicator. And these are based on the provincial environmental quality guidelines for Alberta's surface waters. The limits are essentially noting the levels at which adverse risks on environmental quality are unacceptable. So this is our do not cross line. Beneath the limits, we establish triggers, and they're intended to serve as an early warning signal. And these are the values that are set that are based on historical concentrations. It's important to note that the limits are not intended to be glued up to numbers. The initiation of a management response occurs if a trigger is exceeded. So if we see changes in water quality, we will respond ahead of reaching a limit. A little bit more about limits. As I mentioned, they're set on the most stringent water quality guidelines that exist on our environmental quality guidelines for Alberta's surface waters. And this is important because we can set those guidelines are often based on different uses. They can include protection of aquatic life, recreation, aesthetics, or agriculture. If multiple guidelines exist for any given indicator, we'll always select the most stringent guideline that exists in order to be protective. The trigger values are set based on historical data from each of the monitoring sites. So you can imagine in this graph that it depicts water quality data that are collected from the town of Athabasca station for a specific indicator. Generally, we look to have at least 10 years worth of data so that the historical record encompasses a range of conditions, so both wet and dry conditions, and so we get a really good understanding of the natural variability of water quality at that station. So once we have that the collection of those data, we run some statistics. So one of the statistics that we use is to calculate something called a median. So it looks at the central tendency or 50th percentile of that historical data. We would then use that to look at whether monitored data in the future is either above or below that line. If it's above that line, it suggests that it might be something that we need to pay attention to. A second trigger that we use under the framework is called a peak trigger. This is based on the 90th percentile. It's basically looking at the highs, at the high concentrations, and it gives us an indication of whether the high concentrations are getting higher over time. If they are, it's also something that we want to be paying attention to. So if you can imagine, once we have the framework established, for example, the first 3 years of the framework implementation, we'd have data that are collected year over year. Every year we'd be calculating median values, and then we'd be comparing those median values to the median trigger. You can see that in year 1 and year 2, the calculated values are below that median trigger value, but in year 3, it's above. In that case, that would be something that we would be wanting to pay attention to. It is important to note that because of the way that we calculate these median triggers using historical data, and because of that variability in the data, we do expect that sometimes there might be exceedances of the median triggers. So it doesn't necessarily mean it is a problem, but under the framework, it is something that we would pay attention to. So taking it all together, we've got the triggers, which are those provide the early warning signals, and then we've got the limits, which are the upper bounds not to be crossed that are based on the most stringent water quality guidelines. We've provided this overview today so that when you're reviewing the materials that are available in the fact sheet for the Upper Athabasca Region Surface Water Quality Management Framework on the engagement site, such as the table shown on the slide here, you'll be able to understand it a little bit better. This table shows the list of indicators. It shows those limit values that I've spoken to, and it also lists the trigger values that have been established for each one of the indicators. So this should help with your review. But just recapping the types of management thresholds under the framework, the limits, those upper bounds not to be crossed, values that identify concentrations or the risks that become unacceptable, triggers that provide the signal that conditions may be changing away from historical conditions and that we need to assess the data. And then there's a third type of threshold called targets. Targets describe conditions that we want to achieve in the future. Often they're described as something that's a better water quality than we have currently. We don't currently have any numerical targets established in the framework, but they could be established. And this graph is just intended to show what that could look like. We may make the decision to establish targets that fall below either the trigger or the limit. Okay, the next thing we're going to talk about is the management response. Management response is a series of steps that we would take if a trigger or limit has been exceeded. I first want to draw your attention to the table on the right. This is what we call our management intent table. So it translates the concentrations that we observe in the river to our management intent. So if the concentrations are below that trigger value, it suggests the conditions are at or better than historical, and we would put it in a management level 1, which means that no management response is required. If the concentrations were above that trigger value, we would know that it had been exceeded, and it would be sending us a signal that there could be an undesirable trend or issue developing. In this case, in management level 2, we would initiate a management response under the framework. Similarly, if concentrations exceeded that limit, we would initiate a management level 3, which would also result in a management response. The first step in the management response is to do an investigation of cause. We want to determine why specific issues are emerging. Next, we would then try and determine the appropriate management actions or things that we can do to help improve water quality condition and bring those concentrations down. We then deliver those management actions, assess whether they were effective, and make sure that we're communicating to Albertans on how we're doing. Well, looking a little bit more closely at this investigation, there might be some questions that we'd be looking to answer. We'd be wanting to know if there's anything natural that could explain why those observed concentrations had happened, or why that trigger or limit had been exceeded. We'd be wanting to look to see whether there are any emerging trends over time. Are they happening particularly in winter under ice? Are they happening in summer? We might also be looking at the relationship with flow and seeing if that can help us understand things a little bit better. We'd also be looking to see if there's any other monitoring data that could be used to support the investigation. So this is where we would dive in and start leveraging some of the information that's collected through our tributary monitoring network. So you can see that there's some additional monitoring that happens through our TMN at various locations throughout the watershed shown on the map here. If there are any other data from partners or industry or community-based monitoring that could help provide insight in the investigation, we'd also want to be leveraging that information. In the investigation, it might end up helping us narrow down. We might end up narrowing down into specific subwatershed and determining that that's the specific cause. or we might find that it is more of an extensive issue. We're also going to be looking at land use, information on land use throughout the watershed to inform our management response. So here we've got a map of some of the urban and residential development within the watershed. You can see that it's certain areas where it's more intensive. If we were finding that there were indicators related to urban and residential development that were triggering or crossing limits, then we may want to focus on this type of land use activity in our management response. Similar situation could go for agriculture. If we were seeing nitrogen or phosphorus, for example, at certain stations. You'll also notice that land use is quite variable throughout the watershed. So in the upper portion of the watershed, land use is a little bit different. You might find more forestry activity or oil and gas activity or mining activity. Our management actions can range from education to stewardship to regulatory change. More stringent management actions are taken if a limit is approached or exceeded. So giving you some examples of the types of management actions, they could be stewardship-based. If they were stewardship-based, they might include increased education. So it might be an education program to inform people within a given town or village about ways to reduce river contaminants. It may be education on the state of riparian areas in a watershed. We may be wanting to work collaboratively through developing new municipal programs or planning or policy, or do some additional monitoring or improve our monitoring network together. Lastly, would be regulatory actions. This would be looking potentially at restricting future wastewater effluent sources or reducing existing wastewater effluent sources to ensure that water quality is protected, or potentially to allow for new sources to occur. We have had, through our frameworks in the South Saskatchewan region, limit exceedances that resulted in this management response process. The example here was a limit exceedance for total dissolved solids on the Milk River. In this case, AEP led the investigation, supported by scientists from across the government and outside experts. Through that investigation, we found that total dissolved solid concentrations were caused by natural sources, and it looked like it was specifically due to influence of groundwater. We've summarized those findings in a technical report that's going to be released in the summer of 2021. Our next step is to do a risk assessment to make sure that there isn't increased risk to aquatic ecosystem health as a result of these high concentrations. The findings from this risk assessment will inform the need for any future management actions. So we've talked about the regional objective, we've talked about indicators, we've talked about management thresholds such as triggers and limits, and we've talked about what the response would look like under the framework if those thresholds were crossed. Lastly, I'll talk about reporting and evaluation. Under this framework, reporting and evaluation provides a really key component. Making the information on the monitoring and the management response publicly available is a key priority. The intent under the framework would be to create two types of reports. One would be a status of environmental condition report, which is just the facts report that would be produced annually that will report information on where we're sitting for each one of the indicators relative to the triggers and limits. Then every 2 years, we'd be reporting back to any management response that's been undertaken due to changes in water quality. Okay, let's take it all together and look at the framework in action. So the annual framework implementation cycle would look as follows. Every year, we'd be looking at evaluating the achievement of those objectives. So the objective statement around ensuring current and future uses are maintained. We'd be evaluating the condition of those indicators to see whether we've crossed any triggers or limits. We'd be initiating management response if necessary, and then we would be initiating the appropriate action and reporting back to Albertans. Who's got roles in this? Well, Alberta Environment and Parks is accountable for coordinating and overseeing the framework implementation. So we'll be leading the monitoring through that long-term river network program and through the tributary monitoring network program. We'll be responsible for coordinating and overseeing the management responses and responsible for reporting back to Albertans. We may end up working with other government departments, such as the Energy Regulator, Alberta Agriculture and Forestry, or Alberta Energy, in implementing some of the appropriate management actions. Similarly, we see work with Indigenous communities, stakeholders, municipalities, industry, and WPACs as appropriate, both in terms of engaging you on where we're at on the management response, but where appropriate, getting involved in the development of those management actions. Lastly, I just wanted to make a connection back to decision making. So under the framework, there is a requirement that decision makers consider the findings from the framework in their land and natural resource decision making. So in each decision, it would be a matter of understanding if we've crossed any of those thresholds. If so, for which indicators and which threshold? Is there a management response in place that should be considered? And overall, are we meeting our objective? So those are some key considerations that would be taken into place in day-to-day decision-making with the implementation of the framework. The framework for the Upper Athabasca Region would be issued pursuant to the Environmental Protection and Enhancement Act. This is a little bit different than the Lower Athabasca framework, which is currently implemented under the Alberta Land Stewardship Act. But this framework would initially be implemented through a PIA, and then move forward under the appropriate regional plan under the Alberta Land Stewardship Act. So the engagement opportunity that we're offering you today is to give us some feedback. We want to make sure that we've got our understanding of those regional pressures right. We want to get your feedback on the proposed regional objective, that suite of indicators that's been proposed, and our approach for setting the management thresholds. We'll also be wanting your feedback on the management response, what we do if we cross any of those thresholds, as well as feedback on that monitoring, evaluation, and reporting system. So if you're getting information reported back to you, how would you like it? What format, what frequency? You can provide some of that feedback through the survey, which is open until September 17th, and it's located online, the following URL. At that same location, you'll find some fact sheets that are available for review. If you or your organization are interested in a one-on-one meeting, we are offering one-on-one meetings for key stakeholders and Indigenous communities upon request. And then also making note that the input that we have gathered through this engagement process will be shared back to you on the alberta.ca website. So with that, I'll wrap up and see if there's any questions we can answer.
Excellent. Thank you so much, Sarah, for that great presentation. So we are going to now move into our question and answer session. So I'll invite the panel to turn their video cameras back on and join us on the screen again here. So just a reminder, again, we've got some folks who are supporting the technical aspect of things, so you won't see them pop back up on the screen, but we'll have everybody else join us again. And Jacqueline has joined us as well now here. So, as I mentioned before, we're going to be going through some of the pre-submitted questions and then moving into the live questions. So again, if you haven't opened up that question and answer tool on your Zoom bar, go ahead and do that now. I see some people have found it, and we've got some good questions coming in already. So thank you for that. And then just a reminder for the panel, if you can please introduce yourself. We did sort of a quick round of introductions, but if you can just say who you are and what your role is while you answer the questions as we go through, that would be greatly appreciated. So kicking us off this evening with some of our pre-submitted questions, the first one that I have here comes from Petra, and Petra is wondering, why aren't pesticides included?
Hi, my name is Nathan Ballard. I'm a limnologist in the Athabasca Basin within the Resource Management Branch of Environment and Parks. So this is a really good question from Petra. And there are some technical aspects of it, but essentially our monitoring data, or historical monitoring data, suggests that pesticides are detected very rarely in water quality samples within the Athabasca Basin. This applies to both in the tributaries and the main stem. We do have a pesticide monitoring program. And with such low rates of detection that basically our samples are below detection limits, well beyond what we can develop a robust threshold for. So we can't really have any confidence in calculating a reliable threshold for pesticides when we detect them so frequently. essentially, another way to look at this is as we detect these pesticides so frequently, or so infrequently, sorry, this suggests also that any excessive releases are likely isolated incidents and are probably best regulated in using our compliance assurance programs of existing pesticide application regulations rather than through regulation of land use. And with that, the frameworks do supplement our existing water quality regulations. They don't replace them. So that would be my answer: is if we happen to have advances in our technology to the point where we can detect minuscule amounts with regular frequency, then we might look at developing some indicators for them.
Great, thanks, Nathan. So we have another question here. It was with the first part of that question also from Petra. Why not more monitoring stations on major tributaries?
Thanks, Petra. I'm Craig Emberton, a watershed scientist with AEP. It's a great question and one that's really key to our everyday work. We're thinking about this kind of thing all the time because obviously there's hundreds of tributaries contributing water to major rivers, any major rivers across the province. So we don't have the resources to sample everywhere at all times, obviously, but what we can do is be systematic in how we choose which tributaries to monitor. So we do this by selecting tributaries that drain diverse landscapes across the river basins, so you can capture as many different land activities as possible. And those basins would be proxies for what's happening at other similar types of basins, right? And then the other thing we can do is monitor the tributaries with the largest influences on the water quality of main stem major rivers. So those are the thought process we go through, and those decisions result in what we mentioned earlier as being the province-wide tributary monitoring network. And that includes 7 sites in the Upper Athabasca River region. So in cases where activities or incidences may occur on tributaries we don't monitor, our monitoring program has the flexibility and adaptability to institute what we call focus studies to monitor these smaller systems that may have impacts downstream based on whatever it might be. So a good scenario that demonstrates this might be a human-caused forest fire in the upper landscapes of a tributary system. We have the flexibility to go in and monitor these smaller systems to see what impacts they may or may not have on systems downstream, including at the LTRN stations. So hopefully that answers your question. Thank you.
Great, thank you, Craig. So another pre-submitted question that came from Michael, why aren't any biological indicators being proposed since they better reflect both long-term and cumulative effects?
Yes, thank you for this question. So I'll respond in essentially 4 parts to this one. And first is that some biological indicators were considered in the development of the proposed indicator list. And E. coli specifically was included. Another thing to consider is that in water bodies, biology tends to both respond to and be reflected in water chemistry. So a good example of this would be the growth of algae in response to limiting nutrients like phosphorus and nitrogen, both of which are included in the proposed indicator list. And in some cases, biological indicators may be redundant with the water chemistry indicators, at least with respect to water quality. The third part is that while developing the indicator list, we did go through a pretty rigorous process to eliminate redundancies. We did this so that we didn't wind up with a bunch of indicators all indicating the same thing. So in a nutshell, if we had several different parameters that we analyzed and they all behave the same way at the same times, we pared down the list to choose the most representative ones, or the ones that would give us the clearest signal. One way to think about this is that each one of the indicators in the list actually represents a suite of related parameters or covariates. And it's not necessarily to say either that just choosing one doesn't mean that each of those related parameters can't be followed up on if an indicator exceedance occurs or an investigation begins. And then last thing I might add is that the water quality management framework is one of a suite that may plan for each land use framework planning areas for each of them. So there may be plans to develop biodiversity management frameworks in each of those areas. And so biodiversity management frameworks would interrogate biological indicators more directly and be more specifically targeted towards managing cumulative effects on biota. And I hope that answers your question, and thank you. That was a good one.
Great, thanks, Nathan. So we have another pre-submitted question here that comes from James, and James is wondering who had input into the development of the framework without a regional advisory committee being established for this region.
Thanks, Janine, and good evening, everyone. I'm Kim Lalonde, and I work with Land's Planning Branch in Environment and Parks. And I guess I'm happy to share some information about engagement. The announcement of government's plans to develop these surface water quality frameworks for the North Saskatchewan, Battle, and Upper Athabasca rivers included a commitment to engagement, and this webinar is part of that engagement. Now, I would share that the framework for the North Saskatchewan and Battle rivers does build on some previous engagement that we've had in the past, and there were opportunities at that time for the public, Indigenous people, key stakeholders to provide some comments, but that engagement is now ongoing with this new announcement. And I would also share that, that much of the foundational work for the Upper Athabasca framework that we're talking about this evening, has also been done, but that's been based on the kinds of experience and learnings and so on that we've had from the previous frameworks, and again, based on all of the information that Sarah shared with you. So this is, we are seeking feedback. Sarah, I think, shared some good information to you on the survey and on opportunities to participate. And we're hoping that you get some good information, of course, from this webinar tonight. So hopefully that helps answer that question.
Great, thank you, Kim. All right, so we are going to move now into some of the live questions that we have. So if you pre-submitted a question, we may still get to it later this evening, but we'll shift over into the live questions that have come in. So the first one I have here is from Megan. Megan says, the Lesser Slave watershed makes up a big part of the Upper Athabasca region. There is currently no GOA monitoring stations operating in the basin. The only one on the Lesser Slave River, just downstream of where it meets the Athabasca, was closed in 2019. Are there plans underway to open the station again and perhaps add additional stations in the Lesser Slave? And if not, what are the plans to monitor its large portion of the Upper Athabasca region?
Thanks, Megan. I'll take this again. I'm Craig Emerton here again. Great question. I love questions about our monitoring network. I love that people pay attention to what we do. So this is great stuff. So the Lesser Slave Station just upstream of the Athabasca is part of our Upper Athabasca tributary monitoring network that I mentioned earlier. And these stations can support the framework assessments that occur at LTRN stations. So the Upper Athabasca tributary monitoring network was instated in 2016, and it's been phased in slowly over time. But as of May 2021, this station that you mentioned is operational and is being sampled monthly for water quality during all months of the year. So you had a question about in terms of future stations in the basin. We do have flexibility to do extra monitoring when warranted, and that was through the development of focus studies like I had touched on earlier. So that's great. Hopefully that clarified things for you. Thanks for the question.
Great, thank you, Craig. All right, so next up we have a question for Brian, and I'm just going to read Brian's first question out. So Brian had just asked, what was the statement early on in the presentation that referred to the main stem Athabasca River? And if you didn't see, Rob had typed a response in here just saying that the slide was stating that a surface water quality management framework establishes an approach to monitoring and managing long-term cumulative effects of human activities on water quality in the main stem rivers of a region. And then Brian just has a follow-up question here. So just wondering, what does this mean, or does this mean, sorry, that the surface water quality management framework doesn't look at the subwatersheds? In the Upper Athabasca, a lot of the watershed's land base is actually in the subwatersheds, which Brian goes on to list some of.
Great. Yeah, I can take this question, Janine. No, really good question. I think it's in the same vein of some of the other questions that we've heard tonight, which is around really wanting to understand the water quality conditions in some of the tributaries that contribute to the main stem river. And yeah, under the framework, we are clear that it is the main stem river that has the triggers and limits associated with those indicators. And so that would initiate a management response under the framework. If we do see a management response initiated, and that we are moving into that investigation of cause, it's a very natural place to move to better understand water quality in some of those tributaries. And under our tributary monitoring network, we will be collecting data, and then we got a little bit more detail on that from Craig. So yes, it's sort of the subwatersheds are considered under the framework as part of that investigation of cause. They will be monitored and they will be investigated as appropriate, depending on what we're seeing in terms of some of the changes in water quality in the main stems. If we do, through the monitoring that we're doing in any given tributary, start seeing emerging or concerning issues, we can, under the framework, also initiate a management response to those data that are collected.
Great, thanks, Sarah. Brian, hopefully that provides some clarification for you, and if not, feel free to type another question in on it. All right, so our next question here comes from Michael, and Michael is wondering, how can we ensure that we don't fall into the trap of having a shifting baseline syndrome? That is, that we're using historical data that represents an already degraded condition, especially for trigger and target values.
Yes, okay. So first thing I would point to is that looking at the objective of the framework, or that we're seeking feedback on right now, is the use protection, or protection of current water uses. This includes not only just our human uses, but also ecological uses. Second part of that is that our historical baseline data, that is a defined data set that doesn't change over time, and I certainly don't think it would change in the future without further consultations, if that should become necessary for any reason. And since we have that defined historical baseline, I wouldn't expect that to change, and triggers and limits or triggers are defined from that baseline. So I wouldn't expect any changes in our historical baseline or our triggers and limits, as those are predefined. The only thing I can think of that might change going down the road is limits, and they are chosen from our most stringent guideline values that happen to be available. And usually when those get revised, they get revised downwards and become more stringent. That's as much information as I think I can provide on that one at this time, but thank you for the question.
Great, thank you, Nathan. So we have another pre-submitted question here from Mary Jane, and Mary Jane is wondering, can we as First Peoples receive a testing kit for testing to see how clean or safe the water is to drink?
So I'll answer that. It's Curtis Brock here. I'm a resource manager in the Athabasca region. The EMS is largely focused on source water, raw water drinking sources, and not end of pipe following utilities treatment of the water. So the question about safety is, we don't suggest anybody drink raw water because of parasites and various other things that may be in the water. It should be treated. Drinking water has very stringent quality guidelines that they must adhere to. But for folks that are concerned about drinking water quality at end of pipe in your homes or residence or business, what have you, we suggest that you contact AHS and they will be able to provide you a test kit if there's concern. Thanks.
Great, thanks, Curtis. So we'll go back to another live question here, which comes from Patrick. Sarah mentioned that the Milk River indicators include TDS, or total dissolved sediment, which triggered a management activity due to hitting a trigger and subsequent investigation pointing to groundwater as a source. I don't see TDS as an indicator for the Upper Athabasca. Many of the uses, such as acreages or municipalities, use groundwater sources, which are returned to surface water sources. Is this left out for a reason?
Thank you. That's a very astute observation. And I would refer back to one of the answers I gave a little bit earlier around some of our redundancy analysis, where we looked at how different parameters might behave very similar, do the same things at different times in our historical record, and sort of move in tandem with one another, and how we had removed some of those redundant ones and kept ones with the that give us the clearest signal. I can say that TDS was one of the parameters that we had looked at and we had considered. I'd have to go back and look specifically in the notes, but I'm fairly certain that it was likely removed during that redundancy analysis, so that likely one of the metals in there in the indicator list behaves very similarly. I hope that answered the question.
Great, thanks, or Nathan. Sorry, I'm reading Patrick and saying Nathan, vice versa. And Patrick has another question here. Just wondering about, with the indicator parameters, is there a necessity to differentiate between speciation on some of the parameters, since they may yield different values when tested? Useful if during an investigation there may be other information sources that contribute data to the investigator.
Thanks for the question, Patrick. I can try to answer your question here. So that's a great question. You must have a chemistry background, because of course, how when we monitor for water quality, a lot of these measurements are kind of broad stroke in quotes in terms of what it's measuring, whether it's total phosphorus, metals, suspended sediment. Often we're doing a catch-all trying to measure everything that's in there. And we all know that there's different forms of these chemicals within that total measurement that we capture. So our broad monitoring programs in the long-term river network sites and the tributary monitoring programs, we have the water quality set up where it's trying to capture as many different parameters as possible and as scientifically defensible as we can. But it's still, we still use those sites as screening tools. So if we need to know a lot more about the forms of phosphorus, or if we need to know the different size distribution of sediment in our total suspended sediment samples, we would institute a focused study to look at that further. It's just going to be too much on our resourcing to do all of this speciation that on our samples, but it's something we would look at if need be. That's a great question.
Certainly, and I can probably add to it a little bit. as well, just on the management side of things, sort of different measurements, of course, tell us different things. And being able to tease apart different species, they might be coming from different help us tease out information about what the potential sources might be. And that comes in particularly handy when we go to develop a sort of mitigation strategy or something to help mitigate that. So it's a very good point. And we want to make sure that we're comparing like versus like. Yeah, and I would point to current LARP investigations as which started out as a total nitrogen investigation, and as it moved up the basin, it became important to tease out different forms of nitrogen and begin to assess what those different forms of nitrogen are telling us in different places. So it's a very astute observation, and it is definitely something that we consider in throughout the course of the framework workflow. Thank you.
Great, thank you to both of you. I just see here there's also a follow-up comment from Patrick just saying, following up on Craig's comment on minor tributaries, it wasn't clear to me, but I was under the impression from Sarah's presentation that testing and triggers would be checked only at the monitoring station. Is data collected from the minor stations proactively or regularly, or will they only be addressed in response to a trigger?
Did you want to touch on this first, Nathan, or would you like me to start?
Sorry, I'm just getting caught up again. So I was reading through some questions. If you can get a good start on that, I'll follow up. Thanks.
Sure. Sounds good. So the frameworks are focusing on the main stems of these major rivers, and they use data from our long-term monitoring network stations, which operate year-round, every month in perpetuity. So the monitoring at those LTRN stations supports the frameworks, but they also support a whole range of scientific assessments we do across the province. So the LTRN stations do multiple things, not just support the framework. So when you talk about tributary monitoring stations, they also continue every month in fairly fixed locations to both support the framework. So they do not per se have trigger assessments like the main stem sites do, but if you find that you have triggers or any kind of limit exceedances, things like that, the next step would be to start looking at tributary data to help you explain what you see at those LTRN stations. So they do support, the tributary stations do support these frameworks, but they also do other things as well. So I don't know if you want to add to that, Nathan.
Certainly, and thank you, you jogged my brain in the right direction. So an important aspect of this is to look at not just the existence of triggers and indicators, but to keep in mind that those are derived from monitoring programs, which are more extensive than just the sites where we add these. And so when we identify an exceedance, what would happen is essentially we'd look a little bit deeper into it, just make sure that things are indeed changing and it's not due to natural variability. But then, and if that's the case, then we start to look upstream and try to track the sources of that exceedance or what's driving that change, right? And so that investigation that's started as a result of that isn't limited to just the one station. We would look at all available data upstream to try to narrow down, try to see if we can narrow down the geographical area that might be coming from and the timing of when that might have started, both seasonally and in years as well. So, I hope that answers the question.
Thank you both for both those answers. I was going to add one simple addition here to the question around the interest in the monitoring at the tributary sites. And just noting that, yeah, as part of our engagement, as part of our survey, we do have questions about the type of information that you'd be interested in having reported back to you under the framework. And if there's, I'm sensing that there's an interest in better understanding water quality at some of the tributary stations, perhaps as part of the reporting under this framework. And if there is that desire, that's certainly feedback that we're willing to hear and that you can provide back to us, either by contacting us directly, but even maybe more effectively in your survey responses. And yeah, that's definitely feedback that we're interested in hearing.
Great, thank you, Sarah, and to everybody on the panel for that great response. So our next question here comes from Megan. Megan is wondering, will water quality data collected by WPACs or others be considered as information into the framework?
Hi, Megan. It's Curtis again. We recognize that the WPACs are developing state of the basin reporting products at a fairly regular basis. The AWC as well as the Lesser Slave Watershed Council recognize that your group has done some recent assessment. Part of the indicator selection does do quite a comprehensive literature review and assessment of available data and products by the limnologist. So in this case, Laura and Nathan, to incorporate and consider in the selection of indicators. The main stem is the focus, of course, and I know you've brought up some questions today about the lesser slave being a big part of the drainage. There has been considerable amount of work, as we well know, some partnered with the Lesser Slave Watershed Council, with the province and some independent. But absolutely, we're keen to take in any information that you have that may be relevant for consideration in the development of the EMF. So if there's any additional insights or reports, by all means, feel free to share. I know that was a fairly recent report on water quality in the Lesser Slave. We do have some other complementary work on the main stem through the assessment of the synoptic and some historical analysis as well as it relates to DO and the water management plan for the Lesser Slave River. So, so there is a considerable body of work that's done, and we're more than open to taking in any additional information that you may have that may complement our analysis thus far.
Great, thanks, Curtis. So I see there's just a follow-up comment here from Michael, so I'll just read it out so folks can hear it. Just saying, Nathan, thank you for your response. I'm a big fan of using biological indicators since they reflect conditions in between sampling events. All the indicators that I see being used reflect a single point in time and space. For example, a thermal shock or other shock type event will be unlikely to show up on a monthly or even weekly monitoring, but will show up in the biota, such as aquatic invertebrates. But I do understand the need to reduce redundancy. So just a comment there from Michael. Thanks, Michael, for that. And then we'll move on here to another comment or question from Brian, just saying, again, thanks for that response. Of course, everything is all interconnected. Subwatersheds drain into the main stem, wildlife and birds move throughout the watershed and across watersheds. If I understood your response correctly, that yes, the subwatersheds are included in the surface water quality management framework and will be monitored. And if there are triggers or limits exceeded, there will be a management response. Then I'm highly interested in the network of monitoring stations. It would make sense. There should be a monitoring station at the mouth of each of the major tributaries, as I listed them earlier, and I would expect these monitoring stations would be in 3 spots: the main stem upstream of the confluence, tributary just upstream of the confluence, and main stem just downstream of the confluence.
I'm going to take that one. It's John Owen here, the Director of Watershed Sciences. Thanks for the comment there, Brian. And you're really starting to get into the nitty-gritty of monitoring program design here, which unfortunately for you is my passion. So to deal with the first part of the question you've got, or the comment you've got there, is that the tributary monitoring network, which is not just in the UAR, we also have one in the NSR, so the North Sask, and one in the South Saskatchewan River Basin as well, is really intended to support the data that's coming from the long-term river network. And there's a couple of reasons for that. As Craig has already mentioned, the TMN was started to be phased in 2016. So the data record length we have there is decent in some areas, but it's not quite the same as you would get from the LTRN. So it is that supportive piece. So if there is a management response or investigation triggered under the framework based off the limits identified for the LTRN stations that have been used, then that TMN data can be used to support that. But you've also hit on a key design element, and I would encourage you to go to the Open Government website and type in the 5-year monitoring, evaluation, and reporting plan for LOTIC systems. And what that plan does is actually outlines kind of the philosophy, for want of a better word, of how we approach monitoring for surface water in the province. And one of the key pieces in there is that for the tributary monitoring networks and where we've put them, is it gives us some extra tools that we can use, because what we typically do is co-locate discharge, so water flow measurements and water quality measurements, which means that we can actually calculate yields or mass balance to assessing what's coming in from these particular watersheds. And we can also do that on the LTRN stations for most of them anyway. And that allows us to develop budgets. So just as an example, suspended sediment budgets. And that's the kind of design that you're getting at in the last part of the comment there. So that kind of design ethos is built into the way the TMN specifically has been designed.
Thanks, John. And we do have the link as well for the report that John had mentioned. So we'll put that to your question in here as well, Brian. So it looks like we only have one question left at this point. So if folks have more questions, now is your time to ask. Like we said, we've got a great panel here who can respond to you this evening, and we've still got some time left. So if you have more questions, please go ahead and type them in. But otherwise, we'll go to Patrick's question here saying, I see agriculture use listed. Are there any recreational parameters that need to be added to the limits or triggers? As a user, I see significant recreational activities on some of the tributaries.
So, yeah, Curtis here. So this is, is something that we do take into consideration. Of course, there are parameters that do reflect, potential impact to recreational users. So coliforms, chlorophyll A, but historically, AHS has provided advisories for recreational advisories for contacts, say for blue-green algae. Coliforms on beaches, for instance, are also reported, and advisories provided through the AHS forum. And we'll provide a link in the Q&A here to show where those recreational advisories are listed for many of our lakes. Blue-green algae doesn't historically occur too much in flowing waters. We do have parameters for chlorophyll A, which is kind of ubiquitous to all algae, so it would pick up some species. And we also do have the fecal coliforms E. coli as well as indicators that we're tracking. I recognize there are some areas of the province where there is quite a significant recreational use. Pembina comes to mind. In terms of the campground and use of the river there. But those are all considerations that we took into account in some of our analysis, of course, of tributary level impacts as well. So hope that answers the question. Great.
Thank you, Curtis. And so as Curtis mentioned too, we will also drop the link in there. So for folks who aren't on the panel, you'll see those pop up in the answered questions. So if you are looking for the links, you'll just have to toggle over to the questions that have already been live answered, and then you'll be able to see the links that we're putting in response to the questions that we have there. So it looks like we've got one more question coming in here from Brian. You're sneaking it in here. Good job, Brian. So Brian says, I remember when Minister Nixon made the announcement of these management frameworks, he made specific mention of the concerns about selenium related to coal mining activity. In light of this acknowledgement, would it make sense to closely monitor the areas and subwatersheds where coal mining is occurring?
So I can jump in on that one. I mean, I think one of the key things with the way that AEP approaches its monitoring programs, and this is kind of, both Nathan and Craig have mentioned this earlier, is we really focus on adaptability and having flexible programs that can respond to different needs and different pressures at different times, as well as maintaining some of that core ambient condition monitoring. So essentially, it's a layered approach to monitoring. So, in the case of Minister Nixon's announcement, the network that we have for water quality specifically, does reflect and needs to reflect multiple needs. So we have that long-term ambient condition monitoring that's reflected in the LTRNs, and that data provides a wide range of information, or a range of information on a wide range of cumulative effects of anthropogenic activities, which can vary quite a bit within watersheds and subwatersheds. And that's why the framework is primarily based on the LTRNs. So the stations that I think you were referring to that were on the McLeod River were in place for a specific focused study on a specific activity, and that study is now complete. So as we've said before, since 2016, the additional monitoring we put in place on the TMNs is there in part to address some of these slightly more localized effects in specific subwatersheds. So with the UAR TMN expansion that we have underway, there is a station on the McLeod River. So that will reflect data from activities upstream.
Supplement that under the regulatory approvals of the coal mines, they're also required to collect data fairly regularly at end of pipe and also in the ambient environment. Some of the mines that in the McLeod are in either reclamation or decommissioning, but that is information that we take into account as well, some of the regulatory data in a development of the EMF. So it's another source of data that we're aware of and that we've captured in some cases in our effluent characterization report, for instance. We did look at coal sector data as well, and it did identify a need for certain parameters to be included as indicators for that sector as pressure in the Upper Athabasca. Just supplementary to your response, John.
Great, thanks, Curtis. All right, well, it doesn't look like we have any more questions coming in here. So I'd like to thank everybody for spending your evenings with us and for all of the great questions that came in. We really appreciate it. Of course, as Sarah mentioned, the engagement is open until September 17th, so plenty of time to be able to fill out the survey. Please go ahead and visit the engagement pages that we have set up as well. There's fact sheets and videos and other resources that are supplementary on there. So that can be the hub that you go to find anything that you need to know about these engagements. We'll also be posting a link to this webinar on there as well. So again, thanks everybody for joining us this evening, and we hope to catch up with you sometime soon.